All right. Good afternoon, everyone, and thank you guys for being here. I hate to lean on the old cliche of "Can you believe it's November already?" But it does seem like the year is flying by. So, welcome to our November 2025 installment of ENERCALC Office Hours. For those of you who are frequent flyers here at the Office Hours program, you guys kind of know the drill. For anybody who's new this month, welcome. We do have just a couple of quick housekeeping items to go through before we start our program today. So first and foremost, I just want to get started with a quick sound check. If you direct your attention to the bottom menu of your Zoom window in your browser or desktop app, you'll see the chat tool. Down there, we also have our reaction emoji. Um, so either one of those is fine. If you're able to hear me all right now, just go ahead and give us a thumbs up, give us an okay in the chat, give us a reaction, what have you, and we'll make sure that that's all coming through loud and clear. Perfect. Thank you guys so much. And then obviously we also want to do a sound check and visual check for our primary speakers. So just in a moment here, Mac is going to go ahead and share his screen. And when Mac shares his screen, then if you can hear his voice and see his screen all right, go ahead and give us another reaction. Let us know that he is coming through and we'll go ahead and move forward. Go ahead, Mac.
Hello, everyone, and welcome to another great session of the Office Hours program. I hope you can see the screen and everything is good.
That looks great. All right, now that we have our tech checks out of the way, we are going to go ahead and disable the chat for today, and then we'll move on to some introductions and get going with the program. If you have questions, we do have Q&A dialogue, and we'll talk in a moment about our Q&A stuff. So my name is Seth Roseworm. I'm a senior structural engineer and software developer here at ENERCALC, and most of you know by now our presenter for monthly ENERCALC office hours is Mac Elterhony. Max is a senior structural engineer here at ENERCALC, and he kind of splits his time between technical training for ENERCALC customers, working with the ENERCALC engineering team on the specifications and technical behavior of our software, and then obviously helping maintain a presence for ENERCALC at national and regional structural engineering events throughout the industry. Mac is also a founding and managing principal at Elta Design Group, which is a specialty structural engineering firm. He's been an ENERCALC user for about a decade, so he has a lot of great insight about the needs and daily workflows of our customers. So, for anybody who's new here this month, ENERCALC Office Hours is all about basically providing a channel for open communication between us and our users. We do that through several avenues. We showcase new features and let you know what's the latest, greatest, what's going on in the software as we roll updates each month. We dive deep into optimized design workflows on a module by module specific basis. And then we always do live Q&A with the audience. So every time we have an office hours session every month, we encourage you guys to bring your questions. If there's ever a question that's too involved or it's going to require a lot of research and deep digging, that may be a better fit for our support team, and we can always let you know when that's the case so the support team can dive deep, look under the hood, and get you better answers to your questions. As a minor point of order, you will notice everybody's microphones are muted just so we don't get any echo or feedback while Mac is presenting today. And as I mentioned, we do have open Q&A at the end of every session. To submit a question for today's Q&A, just use the Q&A dialog in the lower dashboard of your Zoom window. If you experience any audio problems at any point during today's session, you can simply refresh your browser if you join via web or close your Zoom app and rejoin the session, as well as using your native audio controls inside the application. If you ever want to rewatch today's program or share it with someone else on your team, every recording of our ENERCALC Office Hours sessions are posted to our Office Hours playlist on ENERCALC's YouTube channel. And you can also access those from the Office Hours page on our website. And with that, I'm going to go ahead and hand it over to Mac to get us going on our program for today.
Again, hello, everyone, and thank you, Seth, for the great introduction as always. Welcome to our monthly Office Hours program. As Seth said, I am Mac Elterhony, and I am excited to be presenting to you today two, not just one, but two modules from the ENERCALC's library of diverse and extensive modules. So I would like to start our session just like always with a brief overview of the overall agenda. The items that we're going to be covering today would be a quick announcement about the PDHs, and then ENERCALC latest build, what's new in ENERCALC, and then we're going to dive into the Rebar development module, live, and then the live load reduction module. And after that, we're going to go briefly over registering for office hours to get notified in the future and wrap up with live Q&A from the audience. So feel free to drop your questions throughout the presentation. So back in May, we started offering zero point 0.5 of a PDA, half a PDH to the attendees, and that represents the guaranteed technical portion of the presentation. The name we use at the certificate, this is important here. So the name that we use to generate the certificate is the same name that you use to enter the Zoom session today. And the email that you used for the Zoom session today is the email that we're going to use to email you the certificate. So please make sure that you are using the name that you want printed on the certificate and the email that you want the certificate to go to. If you got something wrong or you want to change it, you can always just exit and come back again to just click on the same Zoom link again and log in or put the information, the correct information that you need displayed. And in about 10 days or so, you will get a link, an email that has a link to your certificate. And again, the certificates expire in 30 days. So make sure you download them within 30 days of receiving that email. And of course, if there's any problem or the name is misspelled or you lost access after 30 days or you need something, feel free to email us at office hours at enercalc.com. With that being said, we are ready to move on. So first, I'd like to encourage everyone to always check their software, make sure that ENERCALC is using the latest and greatest. And we do release monthly updates, as most of you know, and we want to make sure that you're taking advantage of all of the new updates that we incorporate. So it's good for you to know here that the current build as of today is 2025 1105. This was released last week, so that is the latest build. So make sure that you update to that. A quick refresher on how to update ENERCALC. You can simply click on this update icon in your upper ribbon, and it will open this window right here. You can check for updates if you want, or this is the one that I recommend you do. Is just you click on launch our website, the for our users webpage from our website. And once you launch that page, you can just scroll down and see the software downloads and install instructions. And you can click on this one, click to download Build 20 Updater. This is an updater. This is not a clean, fresh install. So this means that it expects to see ENERCALC on your computer and it just updates the components that changed. But if you don't have ENERCALC at all, of course, then this is the full installer. So very quick and easy process to follow. Next that we have here is that if you want the program to automatically check for updates at program startup, then you should check this button right here to make sure that you're always getting notified and you never miss an update. And a quick note here is for users who are still stuck on this range of a build. So if you're anywhere, if you're ENERCALC right now, if you open it and if you look at the very top right here, if it reads anything in between 2023 830 all the way to 2024 0228, then that means the feature to notify you of the availability of new updates does not function properly. So probably it hasn't been telling you that there is new stuff going on in ENERCALC and you're because it doesn't that function is not functioning correctly. So for those affected, the user will need to update manually just one time just to get everything back in order, and then after that you will be notified of those updates. And again, to do that manual update, we just walked through the process by clicking on the update button and follow the process. So again, the current build is 2025 1105. If you prefer to be notified of the latest ENERCALC updates by email, you can scan this QR code, or you can go to enercalc.com/update-emails, and you can just provide your contact information right here, and you will be notified. This is for those who just want an email to tell them, hey, we just released a new a new build, go download it. Just like a quick reminder in an email. If that's what you want, you can do that right here. So now, if you have not been on the latest build, I want to highlight some relatively new features that surprisingly a lot of people still don't know about them, even though I talk about them almost monthly in office hours. But every time I go to conferences or meet some of our even longtime users, they seem to not know about some of the new features that we have. So. The first thing here that's really exciting is decoupling everything. And this happened in last month's update. And pretty much if you click on the building code and load combinations button, you will now see a different window. The user now has the option to mix and match everything, all codes and design references of different editions, different versions can be mixed and matched. This is a great level of flexibility for our users so they can produce a calculation package that exactly matches what they need. And in this example, you can see that that we are using IBC 2018, but we're mixing and matching ASCE 722. And you can see here, wood is the for the wood code is the NDS 2024. So this yellow highlighting that you can see right here indicates that the reference standard does not match the IBC edition. That's why the ASCE 722 is in this highlighted yellow, orangish color, is because that's not what the IBC references. On the other hand, if you look at the concrete manual, the ACI 318 2014 edition, that is the design standard that is referenced in the IBC 2018, hence it's shown in black. So this way you can keep track of what's not part of the IBC 2018. However, if the user doesn't want to mix and match and they just want to use the standard design standards that are referenced in the particular IBC edition they're using, you don't have to go and try to figure out which one goes with 18 and try to make everything black manually. You can do this by simply clicking on this button. So this is a new button right here. It's called Sync Reference Design Standards with selected IBC edition. If you click on this button, then this button is going to look at your IBC edition that you're selecting here, and it will automatically change all of the reference standards to the ones that follow the IBC 2018. So you can see here that the ASCE went to ASCE 7 went to the 2016 edition, NDS went to 2018 edition, and so forth. So you can always go back by just with a simple click of a button. Keep in mind all the code changes that you implement by clicking on this button right here, all of the stuff that you do that we just talked about, that is only relevant to that specific project file or ENERCALC file that you're working on. So this only applies to the calculations housed within that file. Now, if you want this to be, if you want the code, this code that you selected, if you want that to be used as default for all of your future calculations, even if you go and you create a whole new ENERCALC file, and for a brand new project, for example, and you want to use the same IBC 2018 over and over and over again, that's what you have in your jurisdiction, then you need to click on this button. And what's cool about this button is that once you click on it, which the set default default governing codes, when you click on it, you get this window and it will show you what the old default was. And you can see here, building code was IBC 2018 and the ASCE 2022. They're the same ones that we talked about here. So you can see those are the default codes, and the new codes that we want is the ones that we wanted to change to 2018 and having 2018 to match everything. So those are the new codes. You click save, and then voila, you'll have everything the way you want it. Next is the new tabs that house the ASCE 722 loads and forces modules. We have now a tab for seismic loads, wind loads, and a tab for for other loads. So those are the three tabs that you can see right here. A user can create a calculation for whichever one they want. They can create as many as they want. Previously, the user can only have one calculation per load and forces module, but now you can have multiple. Now, it is important to note that these new tabs will only show up if you have ASCE 722 selected in your code. So if the design loads that you're selecting is ASCE 722, then these three new tabs will start to show up. Now, if you are on an older version of ASCE, so if you're on ASCE 716 or older, then ENERCALC reverts to the old options with the menu to select the load and forces module the way that you typically used to do before the implementation of ASCE 722. So this new, more flexible menu of loads and forces is only available in 722, and it's again, it's just the 722 edition. Now, if you look here, this is I brought this snippet here to show you what it used to look like. So if you're on the 716, for example, or 710, whichever, you wouldn't have those tabs anymore, and everything will come back right here, and then you can pick whichever one you want, which is seismic demands on non-structural components or whatever, wind enclosure, whatever you want from this menu. So if you wanted the other menu or you wanted this menu and you couldn't find it, always go back and check your ASCE edition that you're using for the project. Native load linking within ENERCALC has been an exciting feature with rapid development. Many people, when they go to conferences, they're extremely excited about this. Many people have already been using it and implementing it into their workflows. So I encourage everyone to start making use of this. And for those of you who don't know, load linking is an ENERCALC native feature that gives the user the ability to automatically link reactions from one calculation to another. And it also gives you the ability to change something in one member and have the effects of that change trickle down to all of the supporting members downstream. So again, load linking is currently available in steel beams, wood beams, steel columns, wood columns, and more integrations to come. And if you'd like to learn more about load linking, we created a playlist of short videos on YouTube to walk you through how to use load linking step by step so you can start leveraging this tool in your workflows. And I also added a new video recently, maybe in the past couple months or so, to the YouTube load linking playlist for a full practical example of how to use load linking in real life design applications to transfer reactions from beams to columns. And the good thing about this example is that it covers different materials, so you can take it from a wood beam to wood beam, or from wood beam to wood column, steel beam to wood column. So there's a lot of mix and match going on here and back and forth. So this shows you the versatility of the tool. So again, overall, load linking is a powerful tool that allows the engineers to create a well-connected chain of calculations while minimizing the risk of transcription errors. Another update is the ability to export tabular detailed results from ENERCALC to a CSV file. This is extremely useful for many engineers who want to post-process some of the results outside of ENERCALC. All you need to do is just go to the results that you're interested in. So for example, you can go to the ASD shears and moments right here, and you just right-click anywhere here, and you'll get this menu. This will export all of those intermediate values, such as KL over R or FE critical. Everything will be imported in a tabular format to a CSV file for you. And of course, by popular demand, we made an important update. I think that was about 3 months ago or so, if not a little bit more. But that is to the general footing module. And what we added is this portion right here, where now you can specify top reinforcement. So the module used to have only bottom reinforcement, and you can, of course, specify it in both directions. So the Z direction and the X direction, but only at the bottom. Now we incorporated adding another mesh of reinforcement, which is the top reinforcement layer. And of course, you can do two directions. So again, the X and the Z direction. And we expanded how we report the results to help people make sense or help our users make sense of the results. So for example, you can see here Z flexural negative. That means it's top tension and so forth. So it kind of goes through the various the various reinforcement directions, and it gives you some information. And of course, another item that's been really exciting is ENERCALC for Revit. Especially for those who already use Revit to produce their drawings, this is a no-brainer. ENERCALC for Revit is just a simple plugin that goes directly inside Revit, and you can design structural members fully within Revit without having to export an analytical model or do anything outside of your normal routine. It's a simple point-and-click workflow that allows you to design a member, of course, in a fraction of the time that it would take you otherwise. But this is not just about time, but it's about transcription errors. You don't have to manually carry reactions. You don't have to manually change sizes. You don't have to do anything. Whatever change you do in ENERCALC, it automatically gets implemented in Revit, and vice versa. Whatever you do in Revit, it will change in ENERCALC. So the best thing about it, you can click on a beam. It automatically knows the loads, and if it doesn't know the loads, it'll allow you to tell it where the loads are. It's just guided prompts that if you follow them, you can finish the process very quickly, and it keeps track of what got designed, what didn't get designed, and of course, keep track of all of your reactions. Currently, ENERCALC for Revit supports the design of steel beams, steel composite beams, wood beams, steel columns, and foundations. And so you have a full gravity system that's included in here. And the best thing about it is that if you're in ENERCALC and let's say you change the size from a W8 to a W12, once you click Save and Close, it will automatically bring you back to Revit, remodel that size in real time in 3D space, and you will always have documentation that is 100% accurate to your calculation file. So the last item we have here as far as updates go is that you can subscribe to our release notes. ENERCALC, every month, once we send the once we do the update or release an update, we release notes to outline what changed, what got updated, and what got fixed. So this gives you a good idea about the major changes that that took place. So again, if you want to subscribe to that, you can simply just go to the update icon, same as earlier. Earlier we clicked on this. Now all you need to click on is the subscribe to the new build email updates, and you will be notified directly in your mailbox with everything that has been updated in the new build. So moving on to the focus of today's presentation, the first topic is the Rebar development module. So for Rebar to be spliced or embedded or even just put in structure in general, it needs to be long enough to develop the forces from one side to the other side. So ACI 318 covers this topic in depth. And in today's session, we will focus on the 2019 version of ACI 318. So here's a quick overview of the capabilities of this module. It performs ACI 318 compliant analysis of rebar to determine the required development lengths. You can perform up to 15 rebar development calculations within, housed under one calculation file. So you can just open one and you can have 15 housed right inside of it. This way you don't have to, create too many calculations. You can have them all in one place, multiple of them in one place. ENERCALC performs 3 calculations for each rebar. So it does the straight development, hook development, and splice lengths. And for straight and splice length developments, ENERCALC reports both the tension and the compression development lengths. And of course, you can export everything to a PDF that you can include in your calculation package. So the objective of today's example that we're going to do right now is to walk you through how to use the Rebar development module to determine development lengths based on ACI 318.19. That's critical. And I'm going to go through the theory that's behind it, the various tables, the various provisions, and then we will actually go through a full example. So what we need to do is we have a number 5 rebar, and again, it has to be, we're doing the calculations based on ACI 318.19. We want to determine the straight development length in both tension and compression, hook development length, and the splice length in both tension and compression. We have FY of steel of 60 KSI, and this is normal weight concrete with concrete strength of 4,000 PSI or 4 KSI. Other information will be provided throughout the example that's regarding the various factors that go into these equations. So we're going to start with the straight development in tension. So ACI 318.19, Chapter 25, Reinforcement Details, addresses many detailing concerns, including development lengths. So all of our work today is Chapter 25. Now, specifically, we're going to start with Section 25.4.2.1, this one right here, and I have a snippet of it, and that is the section that talks about the development length of straight bars in tension. And what it says is that you the equations that you need to use, it's going to be based on either A or B. So the way it works, you run through this first part, which is part A. It says that the equations have to be based on 25.4.2.3, which is this table right here, and the factors have to be based on 25.4.2.5. Those are the modification factors for the development of straight rebar in tension. So we're going to use this in combination with that to come up with a development length. Now, it's important to note that there is another section right here that I'm not showing. That's 25.4.2.4. This section right here addresses a more elaborate development length equation that we can use, and that comprehensive equation is not implemented in ENERCALC, so we are not going to be talking about it. But this equation here those are the equations that are going to be addressed. And keep in mind, now this is part number 2, or part B. This says that the minimum is 12 inches. So you'll have to run the calculation, do all the stuff, and then figure out what your development length is. And if it's less than 12 inches, then you have to use 12 inches. If it's more than 12 inches, then of course you use the larger. So it's the greater of the two. Moving on to the other part of this, which is the hook development. So section 25.4.3, this is the development of standard hooks in tension. And 25.4.3.1, that's the section that instructs us that the development length must be the greater of A through C. So part A, this is the standard equation, which is a bunch of factors. This equation, that's an important item here. This equation is different from the equation noted in ACI 318.14. So the 2014 edition of the code or of the design standard has a different equation. Also, the new ACI 318.25 has a different equation for the standard hook and tension rebar development length. So that's why it's very important that you perform these calculations based on the ACI version that's used in your project. This is especially critical to those who have a pre-populated table already is part of their drawings in their general notes or in their typical details. Because if that's what you have, then you need to make sure that you look into it or revise it or make sure that you're using the correct information based on the ACI that you're using for that project, since the values will be different for standard ACI hooked bars. So anyways, to this is the equation right here. And to find all of these psi modification factors, you will need to go to table 25432, which is this table right here. And of course, we have a couple of more numbers to run aside from this equation. You have B right here, which is 8 times the bar diameter, and C is 6 inches. So you'll have to use for the development length whatever is the greater or the greatest out of all of these three values. Next item here we have is section 25.4.9, and that is the straight development in compression. And you can see there's a theme here of how ACI addresses development length. There's always an equation, and there's always a minimum, and there's always a table somewhere with a bunch of factors. So again, for straight bars in compression, the user must pick the greater of the greater length from these numbers right here. So you have a this is a little bit, it's nested. So option number 1 is length calculated in accordance with 9.2, which is this section, or 8 inches. So 8 inches is the absolute minimum, and then you get to here, and then you have to run numbers on option A and option B, and then pick the greatest out of all of these, and that would be your development length in compression. And again, those are your various modification factors. Moving on to the next item, which is the splice development intention. That would be section 25.5.2, the lap splice lengths of straight bars intentions. This is based on the table, which is this one right here. And the code has 2 splice types, class A and class B. So that's shown right here. And the first thing the engineer needs to do to determine, to even figure out where to start, where to look at, they have to look at this right here, which is the area of steel provided divided by the area of steel required. If you are less than 2, then you automatically have to be in class B. There is no way around it. But if you are providing plenty of steel and you're more than 2, then you'll have to follow the table a little bit, and then in certain cases you're allowed to have a class A development or splice type versus class B type. And in all of these cases, as you can see right here, 12 inches is just a minimum. So nothing less than 12 inches worth of development or lap length. And I think the last item we have here as far as code prescribed methodology or design standard methodology is this section right here, 25.5.1, and that is splice development, but that's or lap development, that's for the compression side of things. So this one, they kind of changed it up a little bit. They wanted to make it a little complicated. So for us to determine the lap splice in compression, what we need to do, the first thing we need to figure out is what is the Fy of steel that you're using. That's what you start with. So if your Fy of 60,000 PSI or less, then you will use option A. This is the most common option that everybody uses, which is pretty much the longer of this or the 12 inches. And then option B is if you're in the range between 60 and up to and including 80 PSI. So you follow a similar process where you have a minimum of 12 inches, and of course you have an actual equation to run the numbers on based on the Fy that you're using. Now, then finally, the equation in option C for the Fy that's larger than 80 KSI, they have provided an equation here for you. Now, what makes this a little bit interesting is that everything, as you can see, for option, for example, A and B, they have a hard number, which is 12 inches as a minimum. However, for option C, where Fy is larger than 80,000 PSI, the development length is the greater of the calculated value in option C, which is this one right here. So it's the greater of that, or the value from the lap splice the lap length in tension. That's the interesting part. So this is not a hard limit of 12 inches or whatever. They want you to go and go back and calculate this right here, your LST, your lap development length for a lap splice in tension. Once you figure this out, because it might not be 12 inches, it might be 1.3 LD or it might be 1 LD or whatever. So they want you to look into this and then look into the number that you get from here, and of course pick the longest. So this one is a little bit of a nested loop that they send you through. But most people are in category A, and then a few people in category B, and even fewer people in category C as far as rebar goes. So so either way, all of this is implemented in the ENERCALC module that we are about to cover. So right here, the way that you're going to start a rebar development calculation is the same exact process that you do for all of your calculations. You go to this add button, and then you will get this window with a bunch of tabs. You click on miscellaneous, and then you click on the rebar development module, and it will open up. So first, we'll start by giving this calculation a name. I gave it the most generic name you can think of, which is rebar development calculation. Next, this calculation has different tabs, and this is what I was talking about earlier, where you can house up to 15 different rebar development calculations only under the hood of one calculation. This is nice, so it doesn't crowd your project manager list, doesn't crowd with a bunch of calculations that you really that you can just house here in one place. So we'll click on bar number 1 because that's what we're working on, and as you work your way through the project, you can add more of these here. So bar number 1 is what we're going to be working on. Next, you get this little option right here, and this is print this information. This is an option for you to print or skip printing this particular calculation. So if you click on bar 2 or bar 3, you'll always have an option there that you can, print selectively which ones of these do you want. Because sometimes you want to run a number, but it's not really part of your calculation package, so you don't want it to be printed, but you do want it to be there for internal reference. So this allows you to do just that. And then it allows you also to add a different name for this one. So overall, you can say, rebar development for project X, Y, and Z, and then this would be more towards maybe rebar development of bar number 5, or maybe a specific connection that you're working on that you want to check and make sure you have everything you need. So that's a separate subtask, if you will, or subname that you can give right here to that calculation. Next, very simple. So we're ready to provide some information regarding the rebar to ENERCALC, so ENERCALC can start cooking. For our example, we have a number 5 rebar, and we have an FY steel of 60 KSI. So ENERCALC now knows where to look based on this range. And we have 4,000 PSI or 4 KSI for the concrete compressive strength. And we are good to go here. Now, this part, we have normal weight concrete, so we do not need to check this option. If this was lightweight concrete, you check this option, and ENERCALC will know to bring the proper modification factors for lambda in the calculation, since if it is lightweight concrete. For example, it's normal weight concrete, so we're good to go. And then we move on down the list. So from the previous tables, we can pick the psi factors. So this right here is the straight development. That's the first one that we're going to talk about here. You have a bunch of psi factors here. So lambda is automatically picked for you because you already have normal weight concrete, so you don't have to worry about that. And then you have the epoxy factor, the confining reinforcement factor in compression, and you have the casting position factor. Those are manual entries because the user will have to pick which one they want, because they have to look into the table, the appropriate table. So in this case, it's this table right here, the 25425, modification factor for development of the formed bars in tension. So this is straight bars in tension, so you pick that. So we're going to keep them at 1. Now, the reinforcement grade factor, which is psi G, and the same thing for the size factor. Those get automatically picked up by and generated by ENERCALC. And of course, because those are based on, for example, the size factor for number 6 rebar or smaller, then it's 0.8, and for number 7 rebar and larger, then that would be 1. So it already figures this out for you. And the same thing for the reinforcement grade. If it's 40 or 60 or 80 or 100, it picks the proper values for you. And again, the other factors, you can just manually input them as a user input. Moving on to this option, this is area of steel required divided by area of steel provided or actual, and that's a ratio. So this option allows you to reduce the development length if the area of steel required is, the required area of steel is less than the actual area of steel. So you have this portion right here, this section 25.4.10 allows you to reduce the development length for excess reinforcement. And again, this follows ACI 318.19, and it's very important. So for example, if the area of steel required is something, and then you provided, twice as much steel or whatever, then this number could be, 0.7, 0.8, 0.5, whatever it is, that can be used to reduce your development length. So you don't have to, develop all the 23 inches. Maybe you can just get away with just, I don't know, 18 inches, especially if you're in a tight spot. A few inches go a long way. Now, there are limitations to this, and this is very important because there are times where this reduction is not permitted, and ENERCALC wouldn't know that. So ENERCALC wouldn't know when it's permitted, when it's not. If you do this, it'll perform the calculation. But the user needs to be familiar with this section because there are quite a few exceptions. For example, if this we're coming up with development for rebar that's being used as part of a seismic force resisting system in buildings or structures with seismic design category C and above, so C, D, E, and F, then you can't do this. You're not allowed to reduce your development link. You have to have the full thing, and it's pretty common to have the seismic design category C. So it's just important for you to be aware of the limitations because ENERCALC will not know this because ENERCALC doesn't know what's going on with your building. So that would be something to use with caution. Moving on here to this part right here. This says sufficient clearance and spacing per 25.4.2.3, which is this. So if you have enough or sufficient, if this part of the requirement is satisfied, then you check this. If it's satisfied, then ENERCALC will know to use the top set of equations. That because you already have all the clearances and everything else that you need, you meet these conditions here, then you can use for number 6 rebar and smaller, you use this equation, and of course for number 7 and larger, you use this equation. Now, if you uncheck this, then ENERCALC will move on to use these equations right here at the bottom. So this is very important for you to check and ensure that indeed you do meet or do not meet those spacing and cover and clearance requirements. Another thing worth noting is that the casting position factor and the epoxy factor, so the psi T and psi E, multiplied together shall not exceed a max value of 1.7, and this is per the footnote that is in this area here. So per ACI 25.4.2.5, there's this footnote right here that provides this limit or this upper limit. So nothing for the user to do here. ENERCALC displays this message just to let the user know that ENERCALC indeed considers this upper limit when performing the calculation, so you don't have to worry about it. But this is just for you to know that it does, but there's no work for you there. Once all of this information is plugged into the proper equations, which is, this one over here, that's where we at since less than number 6 bar, the final result is 23.7 inches for the straight development intention. ENERCALC applies the same logic and collect the proper psi factors and then substitute them into the straight development of rebar in compression. So this is the equation for that. So collects all of this information. That's why it collected this one here, the confining reinforcement factor, which is the psi r, because it's part of this equation. In reality, ENERCALC performs both of these equations and looks at the 8-inch and then comes up with the value that controls. And in this case, this equation right here controlled in this particular example, but ENERCALC goes through all of the logic, all of them. Now we kind of jump into the hook development. So the same process again applies here for hook development or development of hooked bars. The psi factors can be picked from the table. However, I want to highlight that the concrete strength factor, this one right here, the psi c, for f prime c equal or larger than 6,000 psi, that factor is 1. And if you're less than 6,000 psi, then you'd have to use this equation to come up with f prime c. And again, this happens in the background, and ENERCALC automatically calculated that value for you as a 0.867. Once it figures out the factors, then it's ready to apply into the equations that we discussed early, and it picked the smallest, or the greatest value of all of these, or the controlling value, and that is 7.4 inches if if this rebar has a standard ACI hook at the very end. Next, ENERCALC calculates splice lengths. Since area provided divided by the area of steel provided divided by the area required is less than 2. That's what we're talking about earlier. In this example, because it's less than 2, then this automatically pushes us into a Class B splice right here. And the way a Class B splice works is that you bring your straight bar development, you multiply it by 1.3, and that number must be, it's either that or, of course, the minimum is 12 inches. So again, ENERCALC goes through this and it provides you that this is a Class B splice, and that's a 30.8 inches. And then it goes through the same process, but for the compression splice now, and it goes through all of these. And in the compression splice, you can see that A is the one that controls because Fy is equal to 60,000 psi. So we're not in condition B and C, but if we were, ENERCALC knows what to do as well. So this concludes the rebar development side of business, and we are ready for the second part of our presentation today, which is the ASCE 722 live load reduction module. ASCE 7 allows the engineers to reduce the live load that's being applied or being supported by a structural member based on many factors, such as the function of the members, the area, or the function that it serves, and of course, the total tributary area to that member. So I'm gonna do the same thing, cover the ASCE equations and tables, and then we'll go through a quick example. This is a short module. So this module addresses 2 sections from the ASCE 722. Section 4.7, that's the reduction in uniform live loads. And section 4.8, that's the reduction in uniform roof live loads. So we're going to start with 4.7, and that is the reduction in regular, floor live loads. You can calculate the reduced live load by following equation 4.7-1. Well, this is the master equation right here. You will need a factor here, KLL, which is the live load element factor. And this factor comes from this handy table that's in ASCE 722. So based on the function that the member and the function that it serves, or what it looks like really, or how it's supported. So interior columns, exterior columns without cantilevered slabs, exterior columns with cantilever slabs. So you go through these, and then of course all other members not identified, including, they give you here some good options like cantilevered beams, edge beams with cantilever slabs, and so forth. You pick the correct KLL factor from this table to plug into this equation. And lastly, there's a footnote that says the reduced live load shall not be less than, this is very important, shall not be less than 0.5 of the unreduced load or the full load. It cannot be less than 0.5 for members supporting one floor. So if this is members are supporting only one floor, like a mezzanine or something, then you can only reduce up to 0.5 of the original load. Now, on the other hand, if that member supports multiple floors, so 2 floors or more, then you can go as low as 0.4 of the original live load. So this is important, and ENERCALC keeps track of this, but it's very, very critical for you to know the limitation. So moving on to, and pretty much, yeah, so once you substitute everything, this is the tributary area. We know KLL, 15 and 0.25 are just numbers, and then this is the load that you have, and it goes ahead and it runs the calculation for you. Moving on here to section 4.8, which is reduction in uniform live loads and uniform roof live loads. And this follows a similar strategy. You have here the roof live load, the reduced live load, equals the full live load multiplied by R1 and R2, and those are factors. And also there is a lower bound limit that you cannot go below that. So if you do your calculations and it tells you your roof live load now is 8 PSF, you can't do that. You'd have to at least use 12 PSF. So the reduction factors, R1 and R2, can be determined as follows. So R1 is really a function of the area that's being supported. So for anything less than 200 feet that's being supported by that member, that's a 1. There's no reduction there. But if you're in between 200 and 600, then you get a linear interpolation value right here. And then lastly, for tributary area larger than 600, you can take a reduction of up to 0.6, and that's when it stops. The same idea applies here to R2. And R2, this is a value or a factor that's a reduction factor that's a function of the pitch or the slope of the roof. So this is in 12. So this is 4 to 12, 1 to 12, and so forth. So 4 rise and 12 run. So if your slope is less than 4, you don't get any reduction. If your slope is between 4 to 12, you get a reduction, and then it maxes out as whenever you have 12 or more, or it maxes out at 0.6. Now that we covered the underlying logic, you follow the same process, add and others, and then live loads here. And that's kind of what it looks like. So when you open it, you just give it a name, live load reduction, various locations. And then this is the first one, which is a roof live load. So you click on, you give it a name, interior roof beam. You click on roof live, and then you give it the unreduced load. You give it the area, and you give it the pitch, and it automatically calculates R1 and R2, and it tells you what that reduction is, and it knows that 12 is the absolute minimum. So if you do the calculations, it'll be a little bit slightly below 12, but the 12 controls. Next is those floor conditions. So you can say, okay, interior beam, interior column, and you can pick here that this is a floor live, not a roof live. And then if anything that supports more than 2 floors and more, you click on this. Otherwise, you're good. Otherwise, it wouldn't, this knows if it needs to bump you against the 0.5 or the 0.4 value that we just talked about right here. So moving on, you have the area. So you can input the area. And then this part right here is the K factors. So those are drop-down menus. So if you actually click on this, you'll get this menu to help jog your memory a little bit and say, okay, well, if it's interior column, it's a 4. If it's this is an interior beam, so it's a 2. The one below it is an interior column, so it's a 4, and so forth. So you can just pick them from here. And of course, there's no roof pitch to this, and it automatically calculates the reduced load for you. So in this case, you went from 80 to 55. And now you have all of your reduced loads in one place, and you can finally apply those reduced loads to your calculations. I think we are ready for live Q&A at this point. So we can took us a little bit longer today, but we are ready to move forward with Q&A if we have any questions.
All right. Let's go ahead and jump into some Q&A here. Speaking of loads and forces, what would be a reason I'm missing ASCE 716 loads and forces calculations? Where have they gone?
It all depends on what you used right here. So if you click on building code and load combinations, this is what you're going to see. If you use, you should open your ENERCALC file. If the design loads right here, if it says ASCE 722, then you will, and we also have this to describe what just happened, but you won't find them here. However, you will find all of there you go. Sorry. Can you still hear me?
Mm-hmm.
Okay, yeah, sorry. So if you click on the add button right here, you will see those right here. That's where your seismic loads, wind loads, and other loads. However, if you're trying to get the old ones, all you need to do, you need to go back and change the code that you're using to ASCE 716. If you do that and you click on save and close, then what happens, you get the old seismic and wind forces and everything, all of those modules, you'll get them right here, and they will indeed disappear from this part. So it's important on what code you're using. If you're using AC 716, then you will get it to look the same old way. But if you are on ASCE 722, and again, I'm going to switch to 722 right here just to show everybody again. If you're on AC 722, they will disappear and they will populate in under the calculations under the add button right here. So go back and review what code you're using.
All right. Next question is more of a comment. You mentioned the development links in 318.25 are different from 318.19. Please mention that ACI 318.25 reduces development links back closer to 318.14, larger change for higher concrete strengths. So definitely some changes coming up in 318.25 that will affect development length. Development team
That's
here at
correct.
ENERCALC is actively working on a variety of different things for ACI 318.25, and rebar development is included in that for sure. All right. Next question. For rebar development, the footnote in one of the tables stated PSI times PSI not to exceed 1.7. Max said that 1.7 is the max. Can you please clarify, confirm?
Yes. Let me bring us back to the presentation. Okay. So let's go back here. You see this calculation right here. So for the straight development of rebar, if you use any of these equations, so you can see here that this is psi t and psi e. Those right here, this is part of your equation. The product of these two numbers cannot be more than 1.7. And this is the footnote right here. So the product of these two numbers cannot be more than 1.7. If you ended up picking, a psi t and a psi e that result in a number that is more than 1.7, let's say a result number that's a 1.9, for example, then you do not use 1.9 and you're limited or you're stopping at 1.7. And that is a good thing because the larger the number at the top, the more development, the larger the development length becomes. So at least it's good that they are indeed limiting this number right here to 1.7.
I'm not thrilled about the fact that I got distracted and pronounced psi as PSI. I was thinking compressor strength. Oh well.
Yeah, I figured.
Oh well, that's all right. All right. After the previous update, I opened a previous project and received an error indicating timber properties were missing. Is this an issue? Corrected an update, possibly an issue on my computer. All right, Timothy, I'm going to recommend that you may want to reach out to the support team if you're having a specific issue in a project file. I don't think there's any known issues specifically with failure of timber properties, but feel free to send over your project file to support@enercalc.com and they can take a look at that for you. Um, where can I find a link of today's recording? We have those always on our office hours page on intercalc.com/office hours, as Mac is showing you guys right now. So
Yeah, so
those are posted pretty shortly after each month's session. They go live almost right away.
yeah, so
And then
just make sure you
also, I think
scroll
you can get
down.
to it in our YouTube channel.
Correct. Yes, you'll have a YouTube channel. I like him here because it's just easier to get to. And so this is intercalc.com/office hours. The cool thing about this page is that you will always know when is the next session, then the topic, and the link to join. So even if you misplace the email, you can always just come here and click on the link to join or add it directly to your calendar. And as you go down here, you see office hours for 2025, and this is the session from October. In a few more days, we will post the November session, which is the one that we're doing today. And as you scroll down, you'll find the 2024 recordings as well. So all of the recordings are going to be available right here in this page.
All right, question from Bill. Does InterCalc provide development length calculations for various ACI codes or just starting with 31819? Development length
Very.
calculations have been in InterCalc for a long, long time, and we've always updated them code cycle by code cycle. Right now, you can get 31814 because that's what's adopted by IBC
18.
2018, 2015, and 2018. And then you can also get 31819, which is what's adopted by 2021 and 2024. So we've always had that feature. It's just always been updated for various code cycles. Right now, 318, 14, and 19 are the only relevant ones.
Yeah, so the ones that we have right now is the 14 and the 18 editions, and actively working on the 25th edition, the 2025 edition.
All right. Next question. Can I compute bar development length using a non-standard steel capacity other than the standard grades? Mac, you kind of went through the drop-down selection there. The reason for that, just while Mac is going back to that, the reason for that limitation is just because we're using the ACI 318 process, and so there's a set selection of a reinforcement grade factor, that psi-G factor, which comes from table 25.4.2.5. That's based on those standard steel grades. All right.
Correct. Yeah, from the drop-down menu. Sorry. Yeah.
Yeah, exactly. Well, Mac, that's pretty much all of our questions for today. You want to wrap us up with upcoming events and a teaser for next month's office hours?
All right. Yeah, absolutely. Let me see here where we at. Yes. Okay. So yeah. So the next office hours session is December 10th. The topic would be the would be module. So I want to thank everyone for your time today and really appreciate your being here. And we're excited to see you next month. And also, these very concerned turkeys are urging you to eat more beef or more chicken this Thanksgiving. So, the Intercalc team and I would like to wish everyone an early, happy Thanksgiving, and we look forward to seeing you next month.
All right. Once again, we thank you guys for being here. We always look forward to having everybody in. Sorry, Michael, I did see your question that you posed, and the team is looking at that as a feature request. If you want to look out, if you want to send that over to support at intercalc.com. Once again, we thank everybody for being here, and we'll look forward to seeing everybody next month. Bring your questions, and we'll see you then.